So the next problem I wanted to discuss is how the resonance structures are going to be possible in some isomeric forms of the same of an ion compared to the other ones. So look at these three structures here. They're all isomeric forms of each other. The only difference is between them is where the negative charge is located. And the question is, will you be able to write resonance forms involving these lone pair on each of this structure? So let's look at the first one. If you take these electrons and if you want to write a resonance form, wherever this electron goes, either towards this carbon or the other carbon, it should be able to, the carbon that is receiving these lone pairs should be able to break a bond on the other side so that it can maintain an octet, so that it doesn't exceed an octet. So this is what you call a vinylic lone pair because it is on the carbon with a double bond. So if you pull these electrons towards the carbon with a double bond O, then you are going to get a structure that looks like this. So these electrons go towards the carbon, this oxygen receives electrons from the bottom carbon, and the new structure looks like this. And as I discussed in one of the last slides in chapter 2 that was posted earlier on Canvas, this lone pair is going to be perpendicular to the p orbitals. So that is one reason it will not be able to conjugate, and obviously even after it conjugates, you're going to get an sp carbon that is highly bent. Therefore this structure is not going to be possible and this conjugation is not reasonable. Okay, so go back to the original video I posted on yesterday night and see the reasoning that was given where these lone pairs cannot be used for conjugation with the p orbitals, and apply the same logic for the structure. So this resonance is not possible. And look at this isomeric form of this ion. The negative charge is now on the second carbon here, okay, and it is still a vinylic carbon, and you will not be able to conjugate this also, because if you conjugate this towards the carbon that is here, you will have to break a bond on this carbon to be able to maintain an octet, to be able to not exceed an octet, and that is going to lead to breaking this CH bond, because if this carbon has to accept electrons from the other carbon, it has to either break the carbon-carbon bond here or the carbon-hydrogen bond here, both of which is going to involve breaking a sigma bond. Therefore that is not a reasonable transaction. All right, therefore this electron cannot be used for conjugation to create a new resonance form either. And finally, look at this isomeric form, which is actually one that you can write a resonance form with. So you pull these electrons in and these electrons will go onto that carbon atom here. Therefore you'll get a carbanion. There is a new double bond between these two carbon atoms. The negative charge is on the third carbon atom, and this electron can further go in and you can break the C double bond O now, and that leads to a new form that looks like this. So therefore among the three forms, this structure is the only one that involves the lone pair in the conjugation. You can still write resonance forms out of these two, but that cannot involve the lone pair. Only this structure can have the lone pair participate in the conjugation.